Hey there. So this is the solving systems of equations by substitution. Now, in this, you'll see this document has multiple pages. We have 1 through 10, then 11 through 20. We're not going to do 11 through 20. That's just too much. So we're just going to stick to 1 through 10. The bottom of this document are the answers, and we can go and check those answers maybe at the end. But let's go ahead and let's do a few of these substitution problems together. So let's stick with blue. Blue's good. All right. So substitution. Ooh, is that not how that works? Oh, there we go. Okay. Wanted to zoom in on it. Substitution is essentially like replacing or plugging in. Now, for example, if we said that y equaled, rather than 6x minus 11, if I just said y equaled 10, if it was simply y equals 10, you know what to do already. You would just simply plug the 10 in here, right? You would have an equation that says negative 2x minus 3. Let me change the color for this. 3 times 10, right? Equal to negative 7, right? And you just multiply, work it all out. That's substitution in itself right there, just like that. You just plug it in. Now, in these problems, we're not plugging in a simple number, but an expression, right? Y is still equal to 6x minus 11, meaning that y and 6x minus 11 are still the same thing. They're equal to each other, right? So one can replace the other. So just like when we plug in 10, we can simply just plug in the expression 6x minus 11. So we're going to take that and input it in for y. So when I take that and I plug it in for the y in the other equation will look like this. It'll say negative 2x minus 3 times y. But remember, we're not going to write the y because we're substituting in y's place. Instead of plugging in like a number like 10 in my first example, I'm plugging in 6x minus 11 because y is equal to 6x minus 11. Those two things can be interchanged. So I've taken the y out and I've plugged in 6x minus 11 in its place, right? Now I still have to finish the rest of this equation, right? It still equals negative 7 at the end. So this is the exact same equation as this, but the y part I swapped out, right? I plugged in 6x minus 11 in where y was. And from here on out, it's just algebra. There's nothing new after this. It's just a matter of doing your typical algebraic steps to solve for x. Because now you'll notice in this equation, there is no y's anymore, right? There is no y. All we have are x's, which means we can solve for x. So the first thing we're going to do is we want to distribute this negative 3 to 6x minus 11. Because before it was negative 3 times y, and we still have to multiply that negative 3 to this expression. So I'll bring this negative 2x down. We don't have to do anything with that first. But when I multiply negative 3 times 6x would be negative 18x. And negative 3 times negative 11 becomes a positive 33. So all I'm doing is simply taking that expression and arranging it into this, right? Distributing it into that. So I'll have equals negative 7. Now from here, there are no more parentheses, but I do have multiple x terms. I'm going to combine these two terms together. So negative 2x minus 18x, all we're doing is simply combining these terms. Negative 2 minus 18 gives us negative 20x, right? And we would bring everything else down, bring the plus 33 down, bring the equals negative 7 down. Now, one thing I want to point out that a lot of students make a mistake on is they think, oh, when they combine these x's, they do the inverse operation, right? They add 2x to cancel it out, and they add 2x here. That's not the way you go about this. You only would add 2x if your intention was to cancel it out and move it to the other side of the equal sign. But that's not our intention. We're not trying to move these terms over here. We're simply trying to put these two terms together. So we follow the operation that they already exist to be. We don't do the inverse. We don't do the opposite. We just connect them the way they are. So negative 2 minus 18 is negative 20x, what we had earlier. Right? We just continue to solve this. Subtract 33 from both sides. We end up with negative 20x equal to negative 40, right? Negative 7 minus 33 is negative 40. And now divide by negative 20. And so 20 goes into 40 twice. A negative divided by a negative makes a positive. So my x is equal to 2. So that's part of my answer, 2. Now keep in mind my answer is an ordered pair. It's going to be an xy point. It's an ordered pair. The x value here is 2. So the x value I'm going to plug into my ordered pair is 2. Now how do I figure out what y is? Well, this is the easy part of the problem. If we know x is already 2, then we can simply go back, we can plug it in, and we can find out what y is. Now, it doesn't matter if we plug x equals 2. It doesn't matter if I plug the 2 in for that x and I solve this equation, or if I plug it into this x and solve this equation. I will get the same answer either way. But since this first equation already has the y by itself, it will be easier to just plug the 2 into here. Let me mute those notifications real quick. All right, it will be easier just to plug the 2 into that equation and get the y. So let's take that, right? We have y equals 6x minus 11. Remember, x is equal to 2, so we're going to plug in 2, right? 6 times 2 minus 11. And so what we get, 6 times 2 is 12. Subtract 11. 12 minus 11 is 1, so y is equal to 1, which means my final answer is the ordered pair, the point 2, 1. And if we went and scrolled down all the way to the bottom here, you would see, hey, there's your answer for number 1, right? 2, 1, just like we said. All right, so let's try number 2, right? It's the same idea, right? We have y is equal to x minus 1. Y and x minus 1 are the same thing, which means I can replace the other equation's y with x minus 1. I can take this y out and in its place put x minus 1 and continue to solve the problem from there. So that's the hardest part usually. It's just taking the information and plugging it in, because a lot of times people plug it in wrong. So how this equation will look if I plug this in for y is it'll say 2x minus 3. That's still the same part of the equation. But when I plug in for y, I'm going to be plugging in x minus 1, right? X minus 1 is equal to y. So plugging in x minus 1, and then we'll have equals negative 1 at the end, because again, that's part of the equation there. So you see, remember, this is where y was. It used to be negative 3 times y, but now it's negative 3 times x minus 1. Simply from plugging it in. So we do the same process we did before, which is just algebra at this point, right? It's nothing new, just, working out your typical algebraic steps. So whenever we have to have those parentheses, we see that distributing, we should always distribute first. You can't really go anywhere until you've distributed into those parentheses. So we end up with negative 2x minus 3x plus 3 equal to negative 1. So 2x stayed the same, but the distributing happened here. We had negative 3 times x was negative 3x, and we had negative 3 times negative 1, which gives us a positive 3. Just like the last problem, we have two x terms to combine. Remember, you're not doing opposite operations. You're not doing something like this. This is a bad thing. All we're doing is sticking them together. We have 2 minus 3. What is 2 minus 3? 2 minus 3 is negative 1. So negative 1x will bring down the plus 3, bring down the negative 1. Continue to solve it like a normal problem. Subtract that 3, because remember, we are canceling that out, right? We are moving it to that side, canceling it out, which is why we do that opposite operation. This ends up leaving us negative 1x equal to, let's see, negative 1 minus 3 is negative 4, right? Continue this problem. We divide by negative 1, because the x is not by itself yet. We end up with x equal to positive 4. So it's good. Remember, our answer is a point, x, y ordered pair. So we know the x value of our answer is 4. All we have to do is plug this in and find y. So you can take it, plug it back in. It doesn't matter, again, which equation you plug it into, but it will be easier to plug it into that equation. So y equals x minus 1. But remember, where x is equal to 4, so we're going to plug 4 in. And y is equal to 4 minus 1. So y is equal to 3, since 4 minus 1 is 3. So my answer is the point 4, 3. So if I scroll down again, I'll see the answer there. Let me zoom out, make it a little faster. Right? 4, 3 was the answer to that problem. All right, let's try number 3. So number 3, I noticed the top equation that has the y by itself. Y is equal to negative 3x plus 5. So again, same philosophy. Plug this in 4y into that other equation. The other equation is negative 5x minus 4y equals negative 3, but not anymore because we're going to plug in the negative 3x plus 5 into the y position here. So our equation will say this. Let's actually, so it doesn't blend with the other problem, let's make this, let's make it red. So our equation is 5x minus 4 times y, but again, we're going to take this y out and we're going to plug in its place the negative 3x plus 5. So negative 3x plus 5. But remember, don't forget, equals negative 3 is at the end of this. So this is, again, the same exact equation that we see here. It's just we've taken the y part out and we've put negative 3x plus 5 in its place. All right, so same as before, we have our parentheses. We have to distribute this negative 4 first. So we have 5x. Now, use this as a negative. That minus sign, use that as a negative 4 rather than just a regular 4. It will help us out. So as we think of this as a negative 4 times a negative 3x becomes a positive, right? Negative times a negative becomes a positive. So that would become a plus 12x, given the fact that it's now a positive number, right? So that minus sign that's here isn't really sticking around because you are taking it, multiplying it with another negative, which converts it into a positive. We still have to distribute more. We have the negative 4 times a positive 5, which will make a negative 20, so that will be a minus 20. All right, so that's distributing. So you gotta be careful with the negatives from time to time. And just as always, we have two x terms that we can put together. Remember, not opposites, just putting them together. 5 plus 12 is 17, so it's 17x. Minus 20 equals negative 3. Simple math here, just add the 20 to cancel it out. We end up with 17x equal to negative 3 plus 20 is 17. Obviously, divide by 17, we're going to get 1. So x is equal to 1. So as we know, the x value of our answer is 1. All we have to do is figure out the y. So let's plug it in, right? Let's plug in 1. Now, let's keep that. Let's use, obviously, the first equation. It will be the more simple one to plug into. So we have y equals negative 3x, but x is equal to 1, so negative 3 times 1 plus 5. So when I work it out, negative 3 times 1 is negative 3 plus 5. Negative 3 plus 5 is 2, so y is equal to 2. So our answer 1, 2. Again, let's scroll down, check to see that that is right. 1, 2, right? Perfect. Okay. And now I'll do number 4. I think we kind of get the idea of generally sort of how this works, but I'll keep showing it to you because it can still be a little bit of a struggle at first, right? So let me do a few more of these. Remember, second equation here has the y by itself. It says y is equal to negative 5x minus 17. So just like before, I'm plugging this in for y, since that's what y is equal to. So the equation will look like this. We're going to have the top equation look like negative 3x minus 3. Now, where the y was, we're going to plug in negative 5x minus 17. Don't forget equals 3 at the end of that equation. So I've plugged this in for y. And now it's just, again, a matter of solving. So just as all the other problems have, we have to distribute into these parentheses first. So remember that negative, be careful about that. A negative 3 times a negative 5 is going to make a positive 15. And since there's an x, that'll be a positive 15x. Again, we have a negative 3 times a negative 17. So I know a negative times a negative makes a positive. 3 times 17 is 51. Okay, there we go. And then bring down equals 3. And just like all the other problems, we have these two x terms that we can stick together. We can combine them. So negative 3 plus 15 is 12. Negative 3 plus 15 is 12. So that's 12x plus 51 equals 3. Continue solving. Subtract 51. And we have 12x is equal to negative 48. If I divide by 12, then I end up with x equal to negative 4. So in my answer, I have negative 4 as my x value. Simply just plug this in, and find y. So the equation we have y is equal to -5 times x. Obviously, we know x is -4. So -5 times -4 minus 17. We ultimately have -5 times -4 is a positive 20. 20 minus 17 is 3. So y is equal to 3. And again, if we scroll down, we will see -4, 3 as our answer to number 4. All right. I'm going to skip ahead just a little bit because some of these near the end can be a little trickier, right? So I'm going to let you do 5 and 6 because they're no different than the first 4 problems. But this one's a little different, number 7. You'll notice this one's different because it doesn't say y equals and then the expression, right? There isn't y all by itself. You have these types of equations. Now, what I do notice when I look at this is I notice immediately this y here. It's a positive y. It has no coefficients. So when I look at that equation, -4x plus y equals 6, I need an equation to be in slope-intercept form, right? I need it to be y equals and then everything else, right? I can't have it if I have other things on the same side as the y. I can't let that happen. So what we're going to do is we're going to take this equation and we're going to rearrange it so the y is by itself. It's pretty simple. All I have to do is move the -4x to the other side, right? If I do that, then the y will be by itself. So let's do that. Obviously, since we're moving it to the other side, we do the opposite operation. So we're going to add 4x, so plus 4x. And now we end up with y is equal to 6 plus 4x. Now, it's very important that these two terms, they're not like terms, so we can't combine them. It's not going to be 10 or 10x or anything like that. They're not like terms, so we have to keep them separate. So let's keep them separate. It's a positive 4x, so we'll write 4x. It's a positive 6, so we'll write plus 6. So it's simply just writing those two terms laterally rather than vertically. But now look, now I've got that equation where y is equal to 4x plus 6. Now I can do exactly what we did in the first 4 problems, which is just take this information, since it says y is equal to 4x plus 6, then I can plug that in to the y, right? And I'm ready to go. Now, before I do that, let me explain why I didn't do that to the other equation. Because I could have just as easily got this y by itself in this equation. But here's the reason why I didn't, okay? In order to get that y by itself, I'd have to move the 5x term over, right? Not a big deal. I would add 5x, right? And I'd end up with -y equals 5x plus 21. Again, just keeping those two terms written horizontally rather than laterally. Now, here's a problem. A lot of times people either forget that this negative is still going to be here, and they don't write it. That's one mistake. So I chose this equation because it didn't have that negative. It was already positive, so people won't make that mistake. You could easily do this. However, you'd have to remember that negative would still be there, and then also you'd have to keep in mind you'd have to divide by a -1 in order to cancel that negative out, because you can't use it if it's a negative there. So you'd have to divide by -1, and that would turn this into -5x minus 21. Now this is perfectly fine. This is usable. You can do it. It's just I preferred to rearrange the other equation, the one up here, simply because it didn't have that step where I had to divide by a negative. And I didn't run into any complications with negatives, right? It was very simple, this one. All I did was move the 4x over, and everything is good to go now, because the y was already a positive y, right? There is nothing wrong with this down here. It's perfectly usable, and you can function with it just fine. It's just because of that negative, it leads to it leads to people making mistakes. That's all. So if you want to make the problem a little easier for yourself, then you can just stick with finding that positive y. It causes less mistakes in the long run. But let's get back to the problem, right? We have y is equal to 4x plus 6. So since we use this equation, we're going to plug this value of y into the other equation. We're going to plug it in here. So here's what that would look like. We would have -5x minus, and then in parentheses, 4x plus 6, right, equals 21. So we've got that plugged in for y. And now we just have to simply solve it. Now you have to be careful again because of that negative. This can still lead you to some issues. Think of this negative as if it were, there you go, as if it were a -1 out there. Because that negative that's there still has to be distributed. And I mentioned that earlier. If that negative is there, you have to make sure you account for it. So when I distribute here, -1 times 4x will make this a -4x, and -1 times 6 will make it -6. So that negative still causes some problems for us, but if you're patient with it and you're focused and you're concentrating, you should be okay. But now, again, same process as before. You have these x terms, combine them. -5 minus 4 is -9. So -9x minus 6 equals 21. Obviously, let's add the 6. This gives us -9x equal to 27. Since 21 plus 6 is 27. Divide by -9, and we end up with x is equal to -3. So as far as my answer goes, the x value is -3. You don't have to do too much struggling. You just have to plug this in to find y. Now, back to the original equations. It doesn't matter if you plug the -3 into the first equation's x or the second equation x. It doesn't matter. Just as long as you plug it in, you should get the same answer. So I'm going to plug it into the top equation just because, that's the one I want to choose. So -4 times x is -3, right? We just figured that out. Plus y equals 6. So when I solve it, -4 times -3 is 12, plus y equal to 6. We subtract 12, then we end up with y equal to 6 minus 12, which is -6. So for number 7, our answer was -3, -6. So hopefully we can see this load in. Yep, there you go, number 7, -3, -6. I'm going to show you all the answers, by the way. So if there's any that we don't get to, you can check them. You can pause the screen, write them down, and then do your work and check them. So this is for 8, 9, 10, 8, 9, and 10. There's also for 5 and 6 if you need it. So, but let's do maybe one more out of the 8, 9, 10 category. Let me do number 8. Okay, now number 8, same issue, right? We don't have it in slope-intercept form. However, and this one's going to be a little bit weird at first. It doesn't have to be y equals. We don't have to have y by itself equal to whatever. All we need is some variable by itself. So even if we had x equals, that'd be fine. We can do the same process. We can take the information we have and we can plug it in for the x term rather than the y term, right? Because just like if it was y equals 10, if I said x equals 10, then we know to just plug in 10, right, where x goes. So it doesn't make a difference if it's y equals or x equals. And the reason why I'm saying that is because we're going to solve for this x here to get this x by itself first. The reason I'm doing that, well, let me do it first and then I'll explain why. So I'm going to try and isolate this x so that I have x equals and then have everything on the other side. So for that equation to work, I have x minus 2y equals 11. I just have to simply add the 2y to the other side. And now I have x equal to 2y plus 11. And now it's x instead of y, but that's okay. What we're saying here is that x is equal to 2y plus 11. So I can take this information, I can plug it into x, remember, because it's x equals, I can plug 2y minus 11 in for the x spot in the other equation. Since I rearranged that equation, I'd have to plug it into the other equation, right? And I can do the same process. It's just the opposite variable, the opposite letter, okay? Now, here's a reason why I did that x instead of any of the other variables, okay? Let me show you. Let's say I solved for the top y. Let's say I tried, and again, I'm showing you this so that you understand why I don't do it this way, okay? Let's say my goal is to solve for that y. Right? First thing I'd have to do is move the x term over, right? And I'd end up with -2y equals 7x minus 13. Everything's fine so far, but you'll notice I'll have to divide by -2, right, to cancel it out so that the y can be by itself. Nothing wrong with this, but what do we end up with? We end up with fractions, right? We end up with 7, or I guess this would be a negative, right? 7 over 2x plus 13 over 2. Or if you put it in decimal form, this would be negative 3.5x plus 6.5. And there's nothing wrong with that. You could use it, but because you're dealing with fractions and decimals, right, you're making this a lot more difficult of a problem now. So that's why I chose, this is a little laggy, so I apologize. Trying to get this all erased. But that's why I chose to find this x, because I noticed by looking at these variables, this x is the only one that didn't have a coefficient on it. I knew that to get it by itself, all I'd have to do is move the 2y to the other side, and I end up with what I got here, right? There's no variable, there's no fraction, there's no decimal, it's very clean, right? But if I wanted to solve for that x or that y, I'd end up with those decimals or fractions simply because each of those terms has a coefficient, negative 7 on that x, negative 2 on that y, or negative 2 on that y. They all have coefficients, which means you'd have to divide those coefficients in order to get that term by itself, which would mean after you divide, you'd end up with those fractions and decimals. So when you're looking to solve for a variable, pick the variable that doesn't have the coefficient, like that x, right? And for number 9 and 10, I'll just go ahead and tell you, in number 10, out of all these variables, the x and these y's, the easiest one to get by itself would be this y here. Simply because you'll just have to add the 5x to the other side, and you don't have to divide anything off of y, since y is pretty much already sort of by itself, right? And then obviously for number 9, out of those 4, I would isolate this y. I would move the 5x to the other side, and then I'd be ready to go, right? So keep that in mind. Sometimes you have to do a little bit of rearranging like this first before you can plug it in. And as far as rearranging goes, pick the easiest one to rearrange that you can find. And then that's how I identify which one's the easiest one to isolate by itself. But anyway, keep in mind, we've got the x by itself, right? So now, remember, this is x equals. So we're going to take the other equation, since we rearranged this one, right? We're going to plug it into the other equation. So negative 7 times x, but now x is 2y plus 11. So we're going to have 2y plus 11 go in its place, right? Continue the rest of that equation. We have minus 2y equals negative 13. It doesn't work any differently. It's just, obviously, you can see it's just y's now instead of x's. But we still have to distribute, same as before. So this would be negative 14y minus 77 minus 2y equals negative 13. Again, same thing. I have these y's I can combine together. So negative 14 minus 2 is just negative 16. So it's negative 16y. Bring down the minus 77. Bring down the negative 13. Just continue to solve this like a normal problem. Add 77 to both sides. This ends up being negative 16y equal to 64. Negative 13 plus 77 is 64. Divide by negative 16. And we end up with y equal to negative 4. So now you'll notice we have y equals rather than x equals, and that's, nothing wrong with that. Y is equal to negative 4. So as far as my answer goes, I know the y value part is negative 4. I got to plug this back into the equation and find x. So again, it's not going to matter which equation we try to plug it into. I'm going to plug it in the second equation here. Seems a little easier, right? So if I plug it in, we have x minus 2y. But again, y is negative 4, so I'm going to plug in negative 4. And just work it out like a normal problem. So negative 2 times negative 4 is going to be 8. So this will be x plus 8. Since the two negatives make a positive, it's plus 8. And then subtract 8 on both sides. We end up with x equal to positive 3, right? 11 minus 8 is a positive 3. So my answer is 3, negative 4 for number 8. And we'll check that out as well, right? 3, negative 4. Perfect, right? So there you go. I'm going to let you do 9, 10, and 5 and 6. If you have questions, just let me know. I know things are crazy these days, and this is just one extra thing to add to your work, and I apologize for that, but I just felt like this is the best way you're going to be able to learn it. So good luck with everything. Let me know if you need any more. Okay? Bye.